Hey, what's up, guys? Today we will be doing rotating image, and actually, the solution of it is pretty simple. So, just notice this one, right? So, you should know what our matrices are and what is some basic operations on them to be able to figure out how to do it. Otherwise, you wouldn't be able to figure it out. So, say you have this thing 147, 258, 369. It just gets 7, 8, 9, 4, 5, 6, 1, 2, 3. Right. But one thing in particular, you notice that this 147 is actually transposed here, 147, and it's then just reversed, right? Similarly, this 456, not 456, sorry, this 258 is transposed to the second row here, and it just becomes 258, and then we reverse it. Similarly, for this third column, just reverse after transposing, and you have your answer basically. So we shall be doing exactly that thing. So I'm just gonna say transpose matrix, and I'm gonna be saying reverse, pass in my matrix as well. So I hope you know what a transpose of a matrix is. Basically, first column becomes first row. That's what transpose is. Second column becomes second row, third column becomes third row, and so on. Cool? Very cool. So we just go private void transpose and metrics. Pretty straightforward, except it might actually be tricky. I take it back. Here, transpose it out. Keep in mind we start with j equal to I, and the reason for that being is if you start with 0, you are gonna just transpose the same element again. It's just not gonna work. With the I1, what's actually gonna happen is, say I'm 147. I transpose it here, 1, 2, 3, right? Both were 0, j and I. Now, I becomes 1, I come here. J becomes 1, 2, I come here, right? So I transpose this row here, then this 4 goes here, 5 remains here, and then the 6 go here. Cool. So that's what the trick was for j equal to I saying. So basically you need a temp to store the value of I comma j, right? Now matrix I j is just gonna be matrix j I, right? That's what transpose is basically. In matrix I j, oh, sorry, ji is equal to 10. I just reverse the thing. All right, here we go. Now reversing it. So basically you just reverse every single row till the half of it. So reverse and matrix for int I equal to 0, I is less than equal to matrix dot length I plus plus for int j equal to 0. Remember, I can go to j equal to 0 now, but let's just go till the half. Even though I know it's an n by n, just for more scalable solution, I'll just do I there as well. And I'll do j plus plus. Remember, you need to go less than the length of half. So if length is 4, half of 4 is 2, you only go to 1 because it's 0 index, so 0 and 1, that's it. If you include less than equal to 2, you're going to go to this 2 here again or 9 here, and then you're going to reverse that too. So you're double reversing. Basically, going back to original doesn't work. So and temp equal to matrix I j, right? And then matrix I j is just gonna be equal to matrix I matrix length minus 1 because matrix dot length index out of bounds minus 1 0 indexing j. Then you copy this, you put this stamp, you hit one code, you hit submit. It works. Now let's see the complexity of it. Basically, O(n) square and O(n) square. So the final complexity becomes O(n) square or O(n) into m if there were different rows and column sizes. But since it's n by n, it's O(n) square. For the space complexity, make sure you do not say O(n) square because it is not at all O(n) square. It is O of 1. Make sure to say O of 1 because these are metrics that were given to us. This is not something we are creating. So you do not account for that. You're just creating this stem. You account for it, which is O of 1. Cool. So this is the solution for it. Hope you guys learn this. And if it comes in your interview, hopefully you guys can do it now.